Okay, so let's talk tension. We have a couple of different ways that you can see tension. You can see tension of a block on a horizontal plane. You can also see it on an inclined plane. Or you can see it free fall. Alright, now, the most important thing that you understand is each of these are two separate systems. So each system you need to do in a different manner. Now, the only thing that is the same for both of them is the acceleration. So here, I'm going to make sure that it looks like my force is pulling down, so my acceleration is to the right, and also here, and also here. This just makes it easier for me. Now, when I look at these, I have a couple of different free body diagrams. So let's go ahead and take a look at this tension for right now. So when I have an object on a horizontal plane, and it's attached to another object that's in free fall, then I need to do two separate body diagrams. So let's make this one purple. And what I have is I have an object with a certain mass and four forces that are acting on it. So I have a vertical force, which is your normal force, force of weight down, horizontal force, which is pulling it, so this would be the force applied, and then an opposite directional force, which is restricting that motion. So this is your frictional force. So I need to make sure that I'm doing my sum of forces formulas for each section. Now my sum of forces for the parallel, so parallel to the surface, is equal to my force applied minus my force of friction. And then I also have my vertical, so my sum of forces perpendicular is equal to my force of weight minus my normal force. Now, because this is on a horizontal plane and I'm moving to the right, then that means that my normal and my force of weight are going to cancel out. So that means that my sum of forces on the perpendicular are equal to 0. Now, my force parallel is going to be equal to the mass of my block times the acceleration, because I know that my sum of forces formula in general is equal to mass times acceleration. So, my sum of forces are always going to be equal to each other. Now, only in the same direction. So if my parallel is in the same direction as my mass times acceleration, so the acceleration of the object, then my mass times acceleration is going to be equal to my force applied minus my force of friction. So I can change this now to mass times acceleration is equal to my force applied minus my force of friction. Now the next thing we're going to do is look at the force diagram for this block, and we're just going to leave it orange, and we're going to call it big M. So big M really only has two forces acting on it. It has a vertical force, which is resisting the motion, and then it has a gravitational force, which is pulling it down. So my force of weight is what's pulling it down, but then I also have a frictional force that is pushing it back up. So this is my, we'll just call it force of friction. So we know that if this block is moving to the right at a certain acceleration, then this block is moving down at that same acceleration. When I do my sum of forces formula, my sum of forces for my orange block is only in the perpendicular. Now this perpendicular, however, is in the same direction as this parallel, which seems kind of confusing, but this string is tying them all together. Okay? So your perpendicular is equal to your force of weight minus your force of friction or your force of tension. So I'm just going to go ahead and change that to force of tension right now, because that's really what's restricting is the force of tension. Now over here, on my purple block, I have a force applied, but if we put it back into the system, then that force applied is really our force of tension. Okay, so I know that I don't have any parallel forces, so my sum of forces for this one is still going to be equal to mass times acceleration. So I have mass, big M, times acceleration is equal to my force of weight minus my force of tension. Okay, so let's find that acceleration. I know that my acceleration is the same for both. And I know that they both have a force of tension. So what I need to do is get rid of that force of tension and figure out what we're actually looking at. So here, I'm going to add them up. I'm going to put them over here. So I have little m times A is equal to my force of tension minus my force of friction. So we're basically cutting out the middleman. My force of tension is on both sides. It's the same force. So it's going to be canceled out, leaving me with my big M A plus little m A, and it's equal to my force of weight minus my force of friction. Now remember, your force of weight is for the vertical falling object, and the force of friction is based upon the weight of the block on the parallel. So combining those, I have A times big M plus little m equals force of weight minus force of friction. And then you solve for your acceleration. Now once you solve for your acceleration, if you're actually trying to figure out what that net force is, then you just take this acceleration and you plug it back in to one of these other formulas.